the MPLS VPN, okay, in the MPLS T also, okay. Here we are using the frame mode. We are using per platform, for example, label space, but we have another type of label space. We call it the per interface. I'm not going to talk about the detail of these two types, but let me to say that we in the cell mode MPLS, we are using the per interface. In the per interface, for every interface, we have different label space. But in the per platform label space, in all of in the platform, we have only one label space. Because of that, when the router tree receives a packet with the label of 300, or in one interface or in another interface, it doesn't matter. This means that R3 again should use this label for forwarding the packet. Because of that, until now, you learned that when the link between the router 1 and router 3 fails, R1 can protect this link by sending the packet or rerouting the packet to the new tunnel, to the backup tunnel with two label, and we can send the traffic to the, for example, end of the tunnel. But here we have another problem, and the next problem is that this link is failed, okay, and now we are using the protected tunnel. In this scenario, we don't have any problem, but maybe in some cases we need to find the best path. You know that this is a temporary function to using two label. We need to find another path, and for finding this another path, okay, we should do it, for example, something. The action of the R1 in this time is that after rerouting the traffic, and this rerouting can occur in less than for example 50 millisecond, or maybe for example 100 or 200 millisecond, okay, we need to inform the router 4, the head end, to finding the other for example other path with the best cost to the destination, with the best behavior to destination. Because of that, now after rerouting the traffic to the for example tunnel, the R1 should send a message, the pass error message, okay, to the router 4, and router 4 now should not for example tear down the path that we are using now. You know that we in the MPLS traffic engineering, we are using the make before break logic. This means that R4 first should find the next best path. After that, it can use that path, and after that, for example, it can tear down the other path. Because of that, for example, in this scenario, after sending the ERR, the R4 now can calculate the best path now from the R4 to R1 to R2, because we don't have any other path, to R3, and then to R5. And after that, it should signal this path with the RSVP. And when the R4 signals this path, okay, it can use this path with only one label. You know that now we are using two label in the path between the router 4 to router 5. But after finding the best path, R4 can use this path, okay, with one label, and also finally we can tear down, okay, the path, the backup path that we used before. And now we have a path from R4 to R1 to R3 to R3 and R5, and we didn't for example lose so huge of the traffic. This is the feature that we call it fast reroute or link protection. I know that you understand this info about this information, maybe 50% or 60% or 70%, okay. Let me to explain again all of the features, okay. After that, if you want, you can stop the video and for example watching the video again. Also, you need to configure it, okay. I will configure it for you. Finally, you will learn the detail. First, let me to reviewing all of the features that I mentioned in this for example notepad file, but in the scenario. Okay, let me to review the fast reroute feature for the link protection. After that, we can talk about the configuration of this feature. Look at here. Here we have the same scenario we saw in the previous picture. You know that here we have a tunnel between the router 4 and router 5, and this is the traffic engineering tunnel, and you know that we call it the protected tunnel because we are trying to protecting this tunnel. Here we have one important for example point. Let me to talk about that protected tunnel. Look at here. As you know, I said that we are protecting the link, not the tunnel. This means that if you have more than one tunnel passing from this link, or you are protecting all of them. Okay, we don't protect only one link. We don't protect only one tunnel. We are protecting all of the tunnels that is passing from this link. Okay, let me to talk about the function of the for example, fast reroute with a new terminology. The first terminology, the first word that you need to know about that is the PLR. We are using the PLR in the traffic engineering fast reroute feature. PLR is the abbreviation of the point of local repair. Why? You know that we are repairing the tunnel passing from the router 1 to router 3, okay? And because of that, this is the point of local repair. Also, we have another term, we call it MP or merge point. Let me talk about the merge point. As you know, we are merging two tunnels here. Here we have, for example, the first tunnel, the tunnel 0, the protected tunnel, and also here we have the backup tunnel, and this is the merge point. As you can see, we are merging these two tunnel, the protected tunnel and also backup tunnel. This router is the merge point because this is the router where the protected tunnel and backup tunnel merge. Okay, let me to talk about the for example function of the T again. In this scenario, now you know about the two new term PLR and also MP. We are configuring the tunnel, the backup tunnel in the PLR, and you know that the PLR and the MP in the link protection fast reroute are two sides of the or two endpoint of the link that we are protecting that link. Actually, we are protecting the primary link with the backup tunnel, okay? Because of that, we call it facility backup, okay? Facility backup. Let me to talk about the detail of the fast reroute. Again, here we are reviewing the concept of the fast reroute for the link protection. Look at here, we have one T tunnel, as I mentioned before. This is the protected tunnel, and also we configured one backup tunnel from the router 1 and to router 3. The configuration is so easy. Don't worry about the configuration. You will learn about the configuration. You have only two new commands. Because of that, easily you can configure the backup and also a backup tunnel and also fast reroute feature. Let me to talk about the concept. Assume that the primary link is failed. Now we are receiving the traffic from the for example router 4 in router 1. Assume that we learned before one label from the router 4. I can write these labels from the router 1. Okay, we received the label 100. This is the label. Let me to write it here. And after that, from the router 3, before then the fail of the link, we receive one label 300. And also from the router 5, we receive the pop label, okay? And also because we have one another tunnel here, we receive one another label from the router 2 in the router 1 in the PLR, the label of the 200, and also from the router 3, we receive the label pop, okay? This is the behavior of the, for example, primary tunnel and also backup tunnel. And you know that because now the primary tunnel is available, we are using only the primary tunnel to sending the traffic. Let me to show you, assume that this is the normal traffic. We can change the color of the normal traffic, okay? And after that, this is our data, any data, and here we have the label of 100 in normal condition, and the label 100 should be swapped with the router 1 to the label 300, the label received from the router 3. After that, we need to forward the data with swapping the label to pop to router 5. This is the normal behavior of the for example MPLS forwarding traffic engineering. Very good. Now after some second or sometimes this link is failed. Okay, because of that we don't have this link. In the normal condition we need to send pass error message from the R1 to R4. Here we have different